This video is going to help you describe a relationship in a scatterplot. A scatterplot is a graph that combines or compares two quantitative variables on an xy plane. Now an xy plane is something you've been using to graph things like in Algebra 1 and Algebra 2, and it's the same kind of here, except instead of making a nice smooth curve, these make dots all over the place, and then we try to find a pattern or relationship between the two. It's very important that you note that these variables, the two variables, have to be quantitative. That means that when you ask the question or when you're collecting data for these, the answer has to be a number. For instance, if you said, how much did you buy your home for? That would be a number, and that would be appropriate. But you wouldn't want to use a variable that you would answer with a word. For example, you wouldn't want to use a scatterplot if one of your variables is what's your favorite color, because the answer to that would be red, green, blue. It wouldn't be a number, therefore it's not quantitative. The explanatory variable is the x variable. That's really easy to remember, explanatory. And the response variable is the y variable. Now the y variable in general is usually what we're trying to predict, and the x variable is usually what we can collect or what we know already. That's not always the case, but that's kind of in general how they work. Because usually a scatterplot's used to try to find a relationship and then make predictions. To describe a relationship in a scatterplot, we're going to use this acronym to help us remember and make sure we hit all the things we need to hit. This acronym is DOFS. Now DOFS stands for direction, outliers, form, and strength. And of course, in all of this, you want to make sure you include context. Now, direction, when you look at a scatterplot, you're basically looking, does it go up or down in general? Sometimes it's kind of scattered and hard to tell, and that's fine. You can say there's no apparent direction, or you can try to say there looks like there might be going up or down or whatever. But the words we use for that are positive or negative. Of course, positive means it's going up as you move to the right. Negative means it's going down. For outliers, this is usually at the end. You will just, if you see anything kind of out of place, or if there's like a clear pattern, but there's one dot or maybe a couple dots that are like way out and where they shouldn't be, you just want to mention those. So this is anything that doesn't fit the pattern, or anything that stands out. And we'll see some examples of that. For form, really what we really want to look for is there any real pattern you see? And the two words we like to use are linear, meaning does it make a line? Or curved. And sometimes when you look at a scatterplot, it looks all scattered all over the place, like the two have nothing to do with each other. And it's really, you can't really see a line or a curve. And you can say that there's really no form. That doesn't happen too often, but in our examples, but it could happen. And then for strength, this is how well do the dots actually fit that form that you just mentioned. So if you said it's a line, do the dots really make a perfect line? That would be really strong. Or they kind of make a line? You might say that's moderately weak, or it's weak. So the words we use for strength are, you can say strong, weak, or you can use the word moderately strong or moderately weak. And it's kind of like a judgment call. You get better at this as you go along. But once you mention all of these things, you're good. You just need to make sure you add context as well. By context, I mean you need to mention something about the real life connotation of that problem. So if we're comparing like test scores with age, you need to make sure you say those words in your sentence, and we'll see that in some examples. So in this first example, we see the scatter plot, and first notice what the variables are talking about. This is the context. Number of chapters, okay, and number of typos found. So it looks like they're reading books and trying to look for typos, somebody's editing, and they're comparing these two variables. Both quantitative, right, because you're counting, and the answer to these is numbers, right? If I said how many chapters are there, you'd give a number. Or how many errors did you find, or typos, you'd give a number, right? So these are quantitative. And then we can clearly see this is the scatter plot is definitely making a very clear, strong pattern. So we want to make sure we hit all the things we want to hit, so we're going to use DOFs. So first, the D. Which direction is it going? Well, obviously you can see this is going up, right? Overall, the more chapters there are, the more typos are found. So the direction, up. Are there any outliers? Well, no, they look like they're all pretty much a straight shot. There's nothing out of the ordinary, so none. For form, to me, this makes a very strong line, so this is definitely linear. And for strength, I think this is very strong. I mean, if you draw a line, like the one I drew, actually a little bit above would be probably better. The dots are very, very close to that line. So I would say this is very strong. You can just say strong if you want, but I think this one is very strong. So to put these in a sentence, or sentences, and you got to make sure you include context, meaning you're going to say something about, put these words in there somewhere. This is how I would say it. There is a strong, or very strong, comma, positive, linear relationship between, and this is where you add context, number of chapters and number of typos found. So that gives me the D, the F, and the S, right? The S is right there, the direction's right there, and the form is right there. The only thing I need to add is the outliers. I also have context, right? Number of chapters, I've got that in there, and number of typos. So all I need to add is outliers. So I'm going to put there are no outliers. And that's it. That's how you describe a relationship. You need to make sure you hit all four of those. Let's take a look at another example. All right, so for example 2, it looks like we're comparing car weight to its miles per gallon. So let's go through our DOFs. We're going to describe this relationship. Let's see, the D, which direction is it going? Well, I think it's clearly going down. As the car weighs more, the miles per gallon go down. Because it's a heavier car, the gas efficiency is not as much. So this is definitely a negative. As far as outliers, well, I'd like to do form first, actually. The form, I think it's somewhat of a line, kind of going down like that. You could argue that it might be a curve. This is kind of a judgment call here. I'm going to call this one linear. You can even say somewhat linear, but to me, if you used a line, it'd be a pretty good predictor, pretty close, somewhat. The strength is somewhat strong. I would definitely say it's moderately strong, probably, because the dots are somewhat near that line. It's not super scattered, but there you go. And then for outliers, I don't think there are any in this case. You might argue that this one might be, but I don't know. I don't think it's far enough to say. I don't think it's far enough to really conclude anything. So anyway, let's go ahead and write our sentences here. Again, you want to make sure you include all four of these things and context. So I need to say something about car weight and miles per gallon. So here we go. There is a moderately strong negative linear relationship between, here's where I add context, car weight, and miles per gallon. And then I would say there are no outliers. Or there are no outliers present. Or you could say there's no apparent outliers. For example 3, I want you to pause this video and try it on your own. See if you can identify all the parts of DOFs and then write a couple of sentences to describe this scatter plot or the relationship in this scatter plot. Okay, welcome back. Let's go ahead and take a look, and then hopefully you can compare and see how you did compared to what I did. So, first of all, I'm noticing the context is we're talking about percent of lower status and population versus their median house prices. Okay, and I'm noticing that there's a definite pattern here. It looks like it's curved. Definitely not linear. Looks like it's very strong curve. Those are actually pretty strong. If you notice, all the dots are pretty much around it. The only one that looks a little bit kind of weird is this one right here, but I don't think it's far enough for us to call it an outlier. So I'd say there's no outliers. And then it's definitely negative because you notice as we move to the right, they're going down. And like I said, probably moderately strong relationship. If you put moderately weak, that would probably be acceptable too, but I think this one's pretty strong. You can see this big old cluster right here. Oops, let me circle. The big old cluster right there that makes it look very strong. So here's how I'd write my sentences. There is a moderately strong, comma, negative, curved relationship between, here's where I add context, percent, and you should probably write these words out, but don't have a whole lot of room here, so percent lower status in population and median house prices. There are no outliers. Sorry for the handwriting here. Okay, hopefully this helps, and hopefully you can get your homework done with this. Good luck.